PhD student and also a member of Intercat. Today, I want to tell you how Einstein proved that light can behave both as waves and also as particles. It's called the wave-particle duality effect. Interesting, right? Yeah, so let's see. So in 1905, Albert Einstein completely changed the perspective on what light is by figuring out the explanation to the so-called photoelectric effect. So much so that later he earned a Nobel Prize in Physics because of this explanation. But what exactly is the photoelectric effect and how does this relate to the wave-particle duality? Well, let me show you with this.
When light hits a material under the right circumstances, it can cause the emission of electrons. That is called the photoelectric effect. The first experiments on this phenomenon were performed back in the late 19th and early 20th centuries by scientists like Philip Leonard and Robert Mulliken. They used very clean metal surfaces under vacuum and illuminated them with light of different frequencies and intensities. Then, they analyzed the electrons that were emitted from the surface, what we call photoelectrons. These experiments showed that the photoelectrons ejected from exposure to light with higher intensities had the same energy as the ones ejected by dimmer light. So the kinetic energy of the photoelectrons was not affected by the intensity of the incident light. However, the brighter the source, the more electrons were ejected. They also showed that there was a cutoff value for the frequency of light in order for the photoelectric effect to happen. Below that cutoff frequency, no photoelectrons were observed. At that time, light was regarded as being a wave, which meant that a more intense beam of light was predicted to eject electrons with more energy than a dimmer beam, and there should be no cutoff frequency. So how do we explain these experiments? Well, the person who did so was Einstein. He realized that these observations could be explained if instead of describing light as a wave, we regarded it as tiny particles with energies proportional to their frequencies. In that case, the particles hitting the surface would transfer the energy to the electrons, causing some of them to detach from the surface and eject. This notion that light could be theorized as if it was made out of small bits was first invented by another scientist, Max Planck. But it was Einstein who recognized that it was actually a reasonable description of the reality of light, and not just a mathematical contrivance.
So that's cool, right? It changes everything, because now we know that light is not only a wave, but it can also be a particle. So if you like this content, remember to follow Intercat everywhere and follow me on Twitter.